Okay, so this is question A2 from the 2020 mock paper. So let's get started. First off, we've been shown an entrance, parabola. The drawing on the right shows AA, our axis, the directrix DD, P is a point on the directrix, and F is our focus. Locate the vertex, draw a portion of the parabola, and then draw a tangent from point P to touch the parabola. So first off, let's find the vertex. I'm just going to roll out this question to make it easier on myself. And first things first, we know that given a parabola, the line of eccentricity is 45 degrees, therefore if I come from where our axis meets our directrix, draw a 45 degree line, that is my ECC line. Similarly, I can now draw a vertical line from my focus, which will give us the latus rectum, or the line that passed through the focal point. And the latus rectum stops where it meets the eccentricity line. That is also a point on the curve because it is the same distance from there to there as it is from there to the directrix. So PF equals PD, so point to the focus equals point to directrix. Next thing, we need to find our vertex, similarly using that rule. So point to your focus is the same as point to the directrix. So if we take the vertex as a point, it means it would be midpoint, so we can bisect this. Or we can just come back at 45 degrees, and this works for all conics. Come back at 45 degrees where it meets our eccentricity line, come back parallel to our latus rectum, and now we have our vertex. Now we can pick a minimum of 2 points between the focus and the latus rectum. I like to pick 3 just to be accurate. So there we go. And these points should end up below the eccentricity line. Well, all the points should really. And then we're going to work all the way up and out. Now we're going to pick, how many does it ask for? It doesn't say in this actually. I think it's usually 3 or 4 as well, so I'm going to pick 4 points on the outside. So 1, 2, 3, 4. There we go. And now all we need to use is our construction. So where the point meets our, or where the lines meet our directrix, not our directrix, our eccentricity line, we need to bring it back parallel to our axis to hit our latus rectum or our focal line. So I'll bring back the inner ones first. So 1, 2, and 3. And then using our compass, put our compass on our focus, take the radius from where it hits our focal line, or the latus rectum, and swing it back to where it came from. It's best not to draw the full arc rather than to just bring it one by one so that you don't get confused. Now I'm after making a mistake because I didn't do both sides. Wouldn't be a video without me making a mistake. And the last one. There we go. There we have 3 points before the latus rectum. 1, 2, 3, and 1, 2, 3. Right, so now we'll get the last 4 points, again parallel to our axis, hit our focal line, you know the drill, and then just complete your curve. So back, again 20 minutes to complete this question in 2021, 12 minutes any other year. Again, sorry about moving the page, it's just it's easier for me to swing it back. Don't forget to go to both sides. While I'm here, I'm actually going to take the point on the end of the latus rectum and flip it around and put it on the other side of the focal line. There we go. Two more to do. And last one. Just need to extend this one a little bit. There we go. And we have all our points. And now just to draw the curve. There we go. We have our parabolic curve. Part B. Draw a tangent to the curve from point P. So this is a construction common to all tangents. If you join your point that touches the directrix, so back to your focus, if you then create a 90-degree angle where that occurs, so if I just use my sliding set squares here, I'm going to bring this down, and if I come 90 degrees to that line from P to F, from F, where that cuts my curve, that will give me my point of contact. All I need to do is join P through there, and there we go. Similarly, if this curve had extended on further, might as well show you here. So if I join again, P to F, instead of going 90 degrees this way, I'm going to come 90 degrees this way. It won't cut the curve this time, but it'll be quite close, I think. And not that close, but you can hopefully visualize what I'm getting at. So if that curve continued, we could then join this point here, and it would also only hit at one point. So it works for all curves, or all conics. And it's a little bit trickier with the ellipse, but it does work. So hopefully that helped. There you go, another 20 marks. So the breakdown of that was 4 marks for finding your vertex, 8 marks for constructing the parabola. So that's usually 2 below the lattice rectum, so this side of the lattice rectum, and then 4 points after your lattice rectum, which would be 1, 2, 3, 4, and that will give you 8 marks. So there's 4 plus 8. Then the method to construct your tangent will be 5 marks for doing this, and then also you probably need to identify 1, your tangent, so don't forget to label it tangent, and 2, construct your normal, which I did forget to do again, so there's 2 mistakes. Your normal is perpendicular to your tangent at your point of contact, not going to your focus. So here, and that's your normal. So good practice, and that will give you your full marks, 20 marks. Thank you.